Hello everyone. Today I will explain the use and operation of automated forklifts. First we come to this side of the vehicle. We can see there is a key here. This is the vehicle's power on-off button. We turn it to the right. We can already see the indicator light is on. The vehicle is in the power on state. Then this button is our manual automatic button. We are currently in manual mode. We toggle it to the right to switch to automatic mode. Here is the emergency stop button. It's a small emergency stop. When encountering a general situation where we need to stop the vehicle, we can just press it. Situation cleared. We release it. Here is a network port. Here is a 9-pin socket. These two are peripheral interfaces for debugging. Here is a large emergency stop. When we press it, the two PLC control modules under the vehicle will power off. Thus the vehicle will also stop running. When we pull it up, the emergency stop state is cleared. Here is one of our manual control modules. We can see there are screen buttons and the AC card delivered with the vehicle. First, after the vehicle is powered on, we need to be here. Ensure this is in manual mode. Currently, we have switched to manual mode. We first need to take out the IC card. Then place the IC card on the keyboard area. After the screen lights up, we press 4 times. Click the number keys to confirm. Then the handle can be used. We move forward. Push the yellow lever. Then the forklift will drive forward. We push the lever downward. The forklift will drive backward. Here, 2 buttons both function as lift and lower. We press down, compress the button. Press the button down. The forklift is in the lifting state. We press the button on the front side. The forklift is in the lowering function. When we are no longer using it, we can return the handle to its original position. Okay, next we will start explaining how to deploy this forklift on site. This is a vehicle touch screen. We click Application. After opening, we find the software in row 3 here. We open it. Then we are here. Click here. Then we can see a network connection here. I am using our company's wireless network. If you are in your factory, please connect to the corresponding wireless network. The password here is, then we click OK to connect to the network. Okay, here it shows network connection successful. Here we can see ROSIP already shows 192.168.123.65. This is a network segment assigned after connecting to this Wi-Fi. Our laptop also needs to enter this IP address in the browser. Enter the vehicle backend. The laptop's wireless network here connects to the same wireless network the vehicle just connected to. Okay, it's connected. Then we enter the corresponding address here. That is, enter the IP address here into the top of our browser. Enter the vehicle backend. Then the following are some operation interfaces of our vehicle backend. First, we need to click mapping mode here. Then we click laser mapping here. Then we can now see a scanning profile of the vehicle. Then we can now start scanning the map. Okay, we have now finished scanning the map. The rule for scanning the map is usually we let the vehicle start from the starting point to perform a circling action. Let the vehicle scan one round and then return to the original position. Then our current map scanning is complete. We can see that the black parts are the buildings we scanned and some relatively static objects. The yellow ones are the map outlines detected by the vehicle's real-time scanning. The two overlap, proving that our vehicle's navigation positioning is in a normal state. Then we now click Finish Mapping here. We need to wait a moment. The vehicle is loading the map. Okay, now we have completed the vehicle mapping. Then we now need to start calibrating the pallet point is a position where the vehicle picks up or places a pallet here. The first step, first load the vehicle with a pallet. Then we drive the vehicle to the position where we need the vehicle to work. For example, if this is the place where our forklift picks up or places a pallet, we then can have the vehicle carry a pallet here like this. Then proceed after determining the position, we park the forklift here. Then click Navigation Route. We choose a current position function. Here, we will set this point named, and then we set it as a pallet point here. Here the distance we default recommend is 1.7. It generates a docking point behind the pallet point. We set the distance of the docking point here. Then we select must turn here. The four fields below are the forklift's safety obstacle avoidance areas. We can see there are vehicle front, vehicle rear, vehicle left, and vehicle right, 4 directions. And the current default parameters are front 30, rear 10, left and right 15 centimeters each. When picking up goods, we might be limited by the environment. The left and right sides generally, the distance can be reduced to half. Then the rear obstacle avoidance distance can be changed to 10 centimeters. If it's too long, the rear obstacle avoidance module easily identifies the pallet as an obstacle. That way we would have a fault when picking up goods. So we generally recommend 10 centimeters. So we click OK. Point A is where the pallet is located. A docking is after the vehicle reaches this point to prepare for picking up the pallet at point A. Then we now go to another point. We can give an example here. We set point B here. Second, we set the second workstation second, which is the second pallet point. We name it B here. Still the same. Choose the distance for the pallet point, docking point here. We still use the default 1.7 meters. And here we select must turn. Then front, rear, left, right distance. We can just continue to use the settings of the previous point. We click yes here. Our 2 points A and point B have been marked. Both points here are for pallet picking and placement. Now we go to calibrate what the vehicle needs charging point. charging point, we generally set it according to the walls in the environment. When arranging the charging pile here, we should place the charging pile against the wall. When the vehicle enters the charging pile, should, after contacting the charging pile contacts, still move backward, stop at about 10 centimeters. Okay, after we dock the vehicle with the charging pile, we click current position here. Then the same thing will happen, the same function interface will pop up. Here we will name the charging pile as point C. Then under type, we choose charging point. Here we still select must turn. Each time we select the same function, it will default to the basic parameters from the last setup. But for the charging pile here, we need to especially emphasize the obstacle avoidance distance in front. Here, we must set it to 0 centimeters. Because the front of the vehicle, when docking with the charging pile, is always docking from the front of the vehicle. If the front obstacle avoidance distance is too long, then the obstacle module will treat the charging pile as an obstacle and affect the vehicle's normal charging, discharging, docking action. So we can slightly extend the distance at the rear. We can change the rear obstacle distance to around 20 centimeters. The left and right obstacle avoidance distances can remain unchanged. Of course, we can also adjust the obstacle ranges in these three directions based on the actual site conditions. We can use and choose them flexibly. Now the charging point has been fully calibrated. Next, we need to use routes to connect these 3 points A, B, and C so that the vehicle can depart from the charging point. Go to point A first to pick up a tray. Then place the tray at point B, or take the tray from point B to point A and then return to the charging pile. We can set up a short process like this. First, we start by planning the vehicle's driving route. So after calibrating the charging pile for the vehicle, we need to calibrate another point behind it. We set this as a route point. We just need to place it roughly in position. For example, here, we set a route point. We can set this point as route point. Route point. We can use other numbers here instead. As for the range of the route point, since this spot is not close to any equipment, it's just a normal passageway, we can configure it as follows. First, we name it 1. All point names can be changed according to our needs. Then this one is a route point, indicating that the vehicle needs to turn here, or it serves as a brief stop point. Then for obstacle avoidance distance here, we can set all directions to a 30 centimeters safety distance. Then we can roughly measure the distance. By default, the distance from the charging point to the first route point is 2.77 m from here. We can set it as 2.26 m, and that's also fine, as long as it's more than 2.5 m. Now we can directly draw a connection between the 2 points. But considering real situations, our pickup position may not have plenty of space. So behind the workstations, we can calibrate another root point behind the 2 stations to simulate a real scenario. Now, our basic flow has been roughly laid out. Next, we'll use the new root function. Select the root edit function. We connect point C to root point 1. When root point 1 turns purple, we need to return click point C so that we have generated 2 routes. We generated a route from point C to point E and generated another route from point E to point C. If we want to cancel this function, we can click on others, such as our drag function. We can cancel the route editing function and thus perform an interface drag. If we need to use the create new route function again, we can click on the screen again. Here, we now click point 1 and then connect point 2. We calibrate point 1 and point 2 again in the same way. We have now also generated 2 reciprocating paths. After we click point 2, if we need to connect point 3 and be doing point, we can see now that for the 2 of them, when we click the next point, it will directly generate a route between the 2 points. So when this happens, we need to switch to route editing. Select delete to remove it. Just select the corresponding route in the calibration list to delete it. So now we continue with point construction. Okay, currently all our points have been connected. After all points have been connected, one thing we need to note is when our forklift comes out from the charging pile, we can zoom in to see. This part of the vehicle is the vehicle icon. This is the direction of the front of the vehicle. And these 2 corners are the vehicle, such fork B. So when we leave the charging point, our fork needs to reverse outwards. We can find the route option in the calibration list. And then we can see here is the route we need to edit is from point C to point 1. We can see C-1 here. We click this option here. We select C to 1 as reverse. For the same reason, when we are at point 2 to point A and point 3 to point B, at point 2 to docking and point 3 to B docking points, we also need a forklift fork B facing towards point A. So we need to select the reverse direction for these 2 routes here. Now we also open with the same function. We can select point 2 to a docking point. Here is reverse. Then we look at point C to B, docking point. Okay, now we have completed the basic settings of the route. We click Save. It prompts that save was successful. Of course, after we complete the entire route planning, we still need to set a standby point. It can also be called in the function bar. We refer to it as the point of origination. We can give the touch point a random name. We also select must turn here, and the obstacle avoidance distance is all set to 30. We need to add this point to ensure the integrity of the entire map. In the entire map, we must include 4 points completed to achieve a complete map. Of course, due to actual needs, we may not have enough area to plan for the vehicle to have a place to stand by. So we can set a point in a blank space of the map. We just need not to connect. We just need to make sure there's no route connection to it. Now we click Save, and it shows saved successfully. Okay, now we finished planning the map. Click on the robot model here, and an options panel will pop up. After we swipe it up, there is an exit option at the bottom. Just tap exit. Then in the application menu bar, we tap Forklift New to open this software here. Then we click Automatic Task. In the previous video, our pallet was at point B, so now we choose to move it from B to A. To create a repeating cycle task, we can then add to B as well. Then we click Start Task, and then click Confirm. Here we need to remember one thing, the most important thing. We must set the vehicle to automatic mode and send the task.